Hi, I'm Alison Middleton and I'm here to talk to you about teaching physics as a non-specialist. So a little bit of background about me. So I have a degree in molecular biology and I originally qualified as a biology teacher. I was lucky early on in my career, I was able to do an additional specialism programme in physics. However, I very much see myself as a non-specialist when it comes to teaching physics, as I haven't done it since A-level. I am currently a head of department in a small comprehensive school in the northwest of England. Being a small school, we actually have no physics specialists within the department, so I am in charge of teaching most of the physics and also supporting other non-specialists with their physics teaching. So what I'm hoping to do today is just talk to you about some of the issues when it comes to teaching as a non-specialist and some of the strategies and resources that I've used to help me and others in my department. So when it comes to teaching physics, obviously I sort of think of it in two ways. There's our core knowledge that we need to know and we need to be able to teach these students. And I've broken this down into sort of three areas. So the first one is our definitions and our explanations. So being able to define words properly and clearly to students in a way that they understand can be difficult for people who aren't specialists. I really enjoy talking about the etymology of words. However, my knowledge in some of the physics words isn't as good as it is for some of the biology words that I know and teach. I've tried to make sure, so in our schemes of learning that we've been writing, that we now have glossaries for every unit. Obviously, it helps the students to know what tier 3 vocabulary they need to know, but it means that the teachers know exactly what they need to teach and those definitions. As well, with the explanations, they've been able to link it to other areas. If you haven't got the same overview, if you don't have the same understanding of physics, it can be difficult to link it to other areas. I've been lucky that in my career I've been able to teach biology, chemistry and physics, so that gives me a really good overview of all the sciences and how they link together. But other people may have been restricted to just teaching one of those until now, and have now found themselves in a situation where they're teaching physics. So being able to link things together, so this is where whole department time really works, when we're writing our schemes of learning and we can share our ideas, talk about things that work well, and how something that I might be teaching in physics, so for example medical uses of radiation, and how that would link into areas of biology. Also, the other thing I think with explanations, it's being able to explain things in as much detail and clearly enough for students can be really, really difficult. Not being able to preempt the questions that you might get asked and the misconceptions that students might have. Now, in terms of questions, there is no shame in saying you don't know. I will hold my hands up when students ask me questions, say, I don't know that, I'm really sorry. I'm not actually a physicist, I'm a physics teacher. I will go away and find that out for you though. And my students really respect that I will hold my hands up and go, I don't know. Brilliant question. Beyond what I know, but I am going to find that out. And quite often they'll go and do some research as well, and it leads to some really interesting discussions. I think there's always a fear of saying that we don't know something, but there is nothing wrong with that. Obviously, if in your department, hopefully there will be some physics specialists that you can talk to, and you should have hopefully schemes of learning that are well resourced as well, that will help with things like explanations and potential misconceptions. So these are things that I want to be written into schemes of learning to ensure that non-specialists can use them. Hinge questions as well to identify possible misconceptions and be able to see if the students do fully understand. Again, as a non-specialist, it can be difficult to identify what the hinge questions in your lessons might be. So schemes of learning with these written in are really useful. Or looking through your lessons, my planning is usually just looking at what I want the students to know, how I will know they know that, and I will actually just think of some questions that I'm going to ask during the lesson to help me determine that. Also, I will try and preempt some misconceptions, some that I've encountered before, but there will always be new ones that I've not met before. So being able to work through those. Now, if you use the Institute of Physics, the IOP website, IOP Spark, there is an area on there about misconceptions that is really useful for you to read, and when you're teaching topics you haven't taught before or you don't feel confident teaching, that will help identify some of those common misconceptions. You can look at trying to make sure your explanations mean you don't introduce those, but also how you can counteract them if the students already have those. Now, the next one, equations and math skills. I think this is where physics gets a bad name. Physics is thought of as being really difficult, and it's this area that people panic when they have to teach physics. They think their math skills really aren't up to scratch. Again, physics specialists within your department should be able to help you, and depending on your maths department as well, it would be brilliant to be able to work with the maths department and have some coordinated approaches to teaching the different math skills. Being able to observe how maths teachers teach certain skills that we need, also knowing when they teach it. So you know that these students have done that in their maths lessons before you need to teach it in your physics lessons. Remember, a consistent approach to how you address equations and rearranging. And this isn't the time or the place for a debate on whether we should use formula triangles, but I quite like a consistent approach. So you might have heard of the FIFA approach. So formula, insert, fine tune and answer, and always laying out the calculations in that way really, really helps. I find if I have a lesson where there are lots of calculations to do, I will do them myself before the lesson. I'll make sure I've worked through the method. I don't just want a list of answers. I want to make sure that the method is clear and I'm laying it out in a way that will help the students. Again, if this is an area that you're lacking in, there's lots of help out there. So STEM Learning run courses on math skills. There's a maths in science, and they also do some specific maths in physics, chemistry and biology courses. We've been really lucky. We've been able to host some STEM Learning courses here. So all members of the department have been able to attend some of these math skills courses. They've been brilliant. Future Learn as well, online courses. There may be some on there to do with maths, and Talk Physics. So again, Institute of Physics, the Talk Physics, lots and lots of courses available. I've done loads of them over the lockdown period, lockdown one, just really helping me with some math skills, areas that I was struggling with a bit. These have been really good. They're really clear, really well explained. Live online courses, and then the videos are available, and you can always get in touch to ask further questions if you need to. So I would highly recommend those. And then following on the experiments and the practicals as well. Again, an area that if you haven't done very much of, you might not be as confident with. I think when we're planning our lessons and we want to put a practical into it, the first thing you need to ask yourself is, what are they learning? Is there actually going to be some learning that takes place because of this practical, or is this a lesson that could happen without it? I think there's a pressure as science teachers that we need to put as much practical into our lessons as possible. I will make sure any practical that I do has a real learning outcome to it, and it will really help those students move forwards with their physics. Obviously, there are the required practicals that we need to do, but anything else apart from those, I make sure that they are needed. This is where lab techs are your best friend. I have a really amazing lab tech who will make sure that my practicals work. If it's one I haven't done before, she'll run through it with me, and I'll have a go at it myself. So having a chance to try these things before you do it in front of the students, making sure you know what the results should be, and if you don't get those results, what those errors are and why you've got those errors, and then being able to link it really clearly to the work that they are doing, as well as doing practicals. See, at the moment, due to the current situation, there are absolutely loads of amazing online videos. Lots and lots of schools and teachers have made some really good, clear videos on the required practicals and other practicals. Use those. Also, you can use them as a learning resource for your students. but use them as CPD for yourself as well. Watch those videos, see how the practicals are being set up, watch the method being explained to you, see how you could then take that into your classroom and explain those to your students. Simulations as well, so lots of online simulations you can use. So PhET, I'm sure lots of you will already use. It's Firefox as well. There's some really good things out there that you can use, both online for online learning, but in the classroom as well on the whiteboard, or if students have access to devices during lessons, they can actually do that themselves during the lesson if you talk them through how to use these simulations. So this is all the sort of the areas of core knowledge. Again, a lot of this, it just requires taking time to work through what you know and identifying your own areas of weakness and finding who or what can support you through these. And once you've done core knowledge, you may have seen a lot of talk recently about Hinterland. So Hinterland runs alongside core. Hinterland are those stories behind the science that they add the depth to your lessons. They help to add a richness to your students' understanding. It's not knowledge that they necessarily need to know, although there are bits of core knowledge, stuff they need to know for the exams, that would fall under maybe the Hinterland umbrella. But being able to talk about the scientists behind the discoveries and behind what you are teaching them. So again, if you're not a physics specialist, you might find that you are lacking in these sort of Hinterland stories. So as a molecular biologist, I spent time in a diagnostic lab. So when teaching GCSE genetics, I was able to talk about my time in the lab diagnosing cystic fibrosis and some of the stories around that, so identifying non-paternity. Because I don't have physics experience beyond A-level, I don't have those real life physics situations that a physicist or an engineer would have, but I do have some stories behind some of the stuff we're teaching. Obviously radiation, we mentioned Chernobyl and Alexander Litvinenko. These are things that are obviously in the news and that we know lots about. I've recently introduced talking about the radium girls. That's something that I've read about, I've discovered. It's not something I've used in my teaching before, but it's another story that I like to put in now. Again, with the Hinterland, it is about maybe doing some research, talking to specialists, but research yourself as well. So IOP Spark, again, there's an area on there called Science Stories, where there's lots of things to help supplement your teaching. Also, if you look on Twitter for hashtag Science Stories, you'd find someone called Bill Wilkinson. He's actually been coordinating, gathering a collection of different science stories. So there will be the information comprehension activities with questions to follow, links to additional reading. And these are designed to be used as a learning resource for your students, but I've actually found them really interesting to read myself and to help add those extra stories into my teaching. And then books and extra reading. Now, I know these things take time, and time for everyone is really valuable, and a lot of us do feel like we're lacking in it. I would highly recommend, as a non-specialist, this book, The Big Ideas in Physics and How to Teach Them. It really covers everything that you need to know. So the big ideas, we've got electricity, forces, energy, particles, and the universe. So it will go into the history, the significance of that, the key figures. So it's really helping your hinterland there. And then it does what to teach, but more importantly, how to teach it. It will give activities and lesson plans and explanations. It will identify misconceptions that students might have. So you will already be aware of some of those. There are key questions in there to ask to help you assess, and along with those questions, model answers as well. So you can model things to students to show them what good answers would look like. This book has been really key to me. I bought it a couple of years ago and I read it cover to cover, and now I just dip into it. When I'm teaching a topic, I'll dip into that chapter and have a little read around it, check that I'm confident with what I'm doing, reread some of the stories and things around it as well. And then also just general books you can buy, which are sort of more physics books aimed at the general public. These are great just for helping sort of understanding. They're obviously written at a level that anyone can access. And the Banana Physics is actually aimed at children. I bought it for my son. Quite an interesting read though. And because it's aimed at children, it really helps to explain things in a clear and simple way. My other thing as well, if you're looking for support, Chat Physics. You're here watching this, so you know about Chat Physics. Tag Chat Physics into questions if you've got them on Twitter. The team are always willing to help. There will be someone out there with answers. There will be people out there with resources who are willing to share to help you. So I hope this sort of gave you a few ideas of things you can do to help support you, and you can see that you aren't alone in being a non-specialist teaching physics. It is very common at the moment, and there are lots of people there who will help you with this. If you've got any questions, if you want to get in touch with me at all, you can find me on Twitter at Mrs. M Loves Sci, or obviously just tag in Chat Physics. Thank you.